Now we're going to minimize some areas. All right. And I want to apologize for the diagram because I did borrow this from the textbook and I don't like the way they have it labeled, but that's okay. Suppose I have a rectangular page that has 24 inches of print. All right, so the area that's got print in it is right in here, and that's 24 inches. The top and bottom margins are 1.5 inches and 1 inches, 1 inch. What dimensions of the paper? Are needed to use the least amount of paper? So the least amount of paper, our primary equation, is going to be the area of the paper, and that's length times width. All right, now what is this? I'm going to call this width and this length, I don't know. This right here is what? It is y plus 2. All right, because I've got this distance y and that's 2 inches. And then the width here, or I guess that's the width, and now my length is x plus 3. Now you know it has 24 inches of print. So my secondary equation is x times y has to equal 24 inches. Let's solve this for y. Y is 24 divided by x. I'm going to plug this in right up here. So the equation I'm going to be working with is 24 divided by x plus 2 times x plus 3. Now let's just go on and multiply this thing out. This is 24, and then this is 3 times 24 is 72 over x plus 2x plus 6. So the area equation we're going to be working with is 30 plus 72 over x plus 2x. Now quite clearly x cannot be 0. So for my domain, I know immediately that x has to be positive. Had I done this the other way with y, you would have seen that y couldn't be 0 either. Had I simply solved for x and plugged in. So we're not going to be able to use our endpoints for when x is 0 and y is 0. All right, and let's just take the derivative of this with respect to x. So this is minus 72 over x squared plus 2. And let's set this equal to 0. When does this equal 0? Well, when x squared is 72 over 2, 36. So when x is plus or minus 6. Again, x has to be positive. Because you can't have a negative area. Now, let's see if we have a max or a min. Let's look at the 3 points. Let's look at when, we're going to go ahead and look at when x is 0, when x is 6, and then when, let's pick 10. 10 is a nice number. All right. Now, what is the derivative when x is 0? Where's my derivative function? Oh, well, I can't use that. I already said I couldn't use that. So let's pick 1. When x is 1, the area is going to be negative because this is going to be 2 minus 72, which is negative. At x equals 6, it's negative 72 over 36 plus 2. Well, the area is 0. That's really good. And at 10, what do we have? We have negative 72 over 100 plus 2, and this is positive. So indeed, we do have a minimum because the derivative goes from negative to positive. All right, so I know I found a minimal. Now, if x is 6, what is y? Well, I know y is 24 divided by 6. So this is 4 inches. So I asked, what are the dimensions of the paper? All right, so I found x and I found y, but I want the dimensions of the paper. So the paper has a width dimension of y plus 2. So it's 4 plus 2, or 6 inches. And a length of x plus 3. And that's x is 6 plus 3, or 9. So the dimensions are 9 by 6. Give it a go. Stop the tape when you're done and finish your homework.